You've been able to provide us at Moonandback with lots of different commentaries and lots of unique perspectives and ideas of how things are taking shape commercially. And how is it that you see that, just projecting for the next couple of years, that the commercial industry, especially the suborbital tourism industry, will be able to take off? And other than the science experiments, what your guys' role will be in accomplishing those goals?
Interesting question. I think that we're at the cusp of a new era here. Commercial spaceflight really has not developed in a robust way due to the fact that it's been so expensive in the past. The only payloads that really exist commercially to any significant degree are communication satellites. It's as if the only use we had for commercial aviation was a few helicopters to put these radio towers on top of mountains, and no one had been able to do anything else. What we're going to see in the next few years is a paradigm shift. With these suborbital vehicles, access to space is going to become radically cheaper, and we're going to see new classes of applications which have not even been thought of in the past. It's much like the transition from dirigibles to fixed wings airplanes. You know, people did a limited amount of travel in airships, but once people were able to get this new technology and were able to fly freely through the air in a controlled fashion with heavier than air powered airplanes, suddenly it completely changed the paradigm and completely changed the application. Aviation very quickly went from being this expensive form of luxury travel on airships to being something which was commonplace and routine. You know, even within my own lifetime, I'm old enough to remember when people still spoke of the jet set, the people who could afford to fly in jet airplanes. That's not a term you hear anymore because everyone is able to fly today. No one travels from New York to Los Angeles by bus anymore, or train, unless they just want to see the scenery on the way. We're going to see a very similar transition in space, and in a few years, suborbital will be the way most people go into space. Right now, there's a lot of skepticism. People think of suborbital space flight as being, well, it's not really space because it's not going to the ISS. It's not going to the moon or Mars. It's not considered really sexy. In much the same way that the first microcomputers, when they were introduced, were not considered sexy. You know, people in the computer industry laughed at them. They called them toys. They called them game machines. They couldn't run COBOL. They couldn't run Fortran. They didn't have these huge applications developed by the computer gods who wore the white coats and lived in the machine rooms. But they did make computing accessible to a wide range of users who had never had it before. And in the process, they opened up the computer industry to the development at a rate which was never possible before. In 1975, Business Week came out with a cover story with a picture of Seymour Cray talking about his new supercomputer, and it had a picture of him and his computer, and the headline said, "The machine that will change the world." At roughly the same time, Popular Electronics, this small hobbyist magazine which almost no one read, had a cover story with another computer on it. And it didn't say the machine that will change the world. It said the Altair 8800, a computer you can build. But ultimately, it was the Altair 8800 and its descendants which changed the world. And now we have this situation where I have more computing power in my iPhone than Seymour Cray had in any of his supercomputers that he built. And this is the sort of rapid progress which is possible when you have large numbers of people working on a problem, pursuing it in parallel courses in multiple fashions, bringing their own ideas to the table. And this has never been possible with space, because space has not been accessible to large numbers of people before. It's something which has been attainable only by NASA, by government contractors, by a few very fortunate, well-funded university researchers. But in the next few years, space will be open to all of the above, plus the citizen science community, the hacker spaces, the amateurs. Everyone who wants to go will be able to have access to space for a few $1,000s. Once this happens, you're going to see this tremendous variety of new ideas tried out and tested, and you're going to see discoveries like never before. There's a lot of skepticism and a lot of cynicism out there about how we've tried to develop commercial applications of space and we've failed. We haven't discovered anything of value. People say, well, we've experimented with all of these proteins in space and we haven't found anything really which is a commercial value, which it turns out is not actually true. Schering-Plough did an experiment aboard the International Space Station, and they discovered a new form of interferon for treating hepatitis C, which they are now marketing commercially. This is one of their best-selling drugs. But this is only one example, and the reality is only about 200 proteins have actually been studied in weightlessness. There are an estimated 2 million proteins in the human body. We have not even begun to scratch the surface of the research possibilities. What we need to do is to make space research accessible and affordable. Every high school student in America should have the opportunity to do a science experiment and fly it into space before they leave high school. We should make access to space part of the normal curriculum, as accessible and ordinary as a microscope. We should allow every scientist in the US who has an idea and wants to try it out in space to have access. This is what we're going to find happening in the next few years with these new low-cost suborbital vehicles.